Hello, I want to solve a problem, a simple problem from roller coaster physics. Roller coaster physics here. Okay. Here at the top, I have some known data, known information as the weight of the train, 800 kilograms, and the initial velocity, initial speed 3 meter per second. As we all know that energy doesn't dissipate, it just changes from one mode to one another mode. I know that here at the top, because my speed is very small, I have the least kinetic energy and the utmost potential energy, and vice versa at the bottom I have because the h here is near the ground and h is 0, so my ngh is 0, so my potential energy is 0, and my kinetic energy as a result of the very high speed 35 meter per second is utmost. Here 35 meter per second is vc at the bottom of the train. Okay, now the problem is what is the height between b and c. I mean from here at the top to the ground at c, we call it h1. Okay, I have a screenshot from this page into my Word here. Okay, let me just show it here to you. Roller coaster detectives advanced sheet. Okay, here I want to calculate h1. I have put down the information, I mean the known data m, vb and vc. I want to calculate h1. I just know that energy doesn't dissipate, so they are the same. vb plus ub is the same as vc plus uc. Here is very important because we know that energy doesn't dissipate. Okay, here, so this equation is always true. Okay, by simplifying the equation, as I see m and m in 4 equation is the same, so I simplify the top equation and I arrive to that equation here. Okay, this is simplified. Okay, and at the bottom here, by inserting the known data into the equation, I just arrive to my h1. You can at home or at a workshop, you can just solve this equation by this data, and you will see that h1 here is 62 meters. Let me have a comparison between my solution and the book solution here. Okay, the answer is 62 meters. It's almost 62 meters. Now let me just return back to my Word. I have a screenshot from my no limit here. Okay, my no limit here. This is a real roller coaster I have designed in no limit 2. The green lines are speeds. Okay, and at the bottom I have the most kinetic energy, and my speed is about 119 or about 120 kilometers per hour. And at the top I have the least kinetic energy, as I explained earlier, and the utmost potential energy. Here the speed is very teeny, very small, is about 10 kilometers per hour. I want to calculate h1 from this point here. Can you see my mouse? I am circulating here to the bottom. Okay, to here. Okay, let me return back to my Word. As I solve the problem here, h1, I want to solve it for my real roller coaster in no limit 2. h1 here, vb is 10 kilometers per hour. I divide these to 3.6 to arrive to 2.7 meter per second. m is the same as the problem, 800 kilograms, and we see at the bottom is utmost here. Can you see my mouse here? Okay, my screenshot exactly beneath C. 119 kilometers per hour is 33.2 meter per second. And if you can see my mouse here, estimated speed resulted in no limit 2 is shown 119.816 kilometers here. Okay, and I have solved these problems again in here, and I arrived to a conclusion that h1 is 56 meters. If I come back to my no limit 2 here is 60 meters, and here is about 4 meters. You can see my mouse here. Here my mouse is circulating around here is 4 meters, and if I if I minus 62, 4 is 56 meters. So h1 from the toppest point to the bottom is 56 meters. Thank you for watching this video. In the next video, I will try to show the speed, tangential and centripetal acceleration in my roller coaster physics.